Hi, my name is Saqib Aziz. I'm a research associate at the University of Arts in the Department for Structural and Computational Design, also called KET. Today I'm going to present a paper called Towards a Multifunctional 3D Concrete Printed Slab System, which is a collective research endeavor at the University of Arts at our department, and I've published this with my colleagues, which are mentioned in the paper. The whole idea behind this paper is we are looking at new means and technologies to construct in the future in the AEC industry. This, of course, is mapped out by the current alarming trends with the world population growing, and alongside that, the CO2 emissions that are also growing exponentially. And of course, this is caused to a large part also by the AEC industry, because we're still using steel and concrete as a prevailing method to create our building structures. And if you just think about it, that we each month build New York City as the building mass, it might be a good idea to think about new strategies which are more sustainable for the future. So we did some pre-studies. One was the C3 Pavilion, which is the first building using a carbon concrete composite as the construction method, and is currently being constructed at the TU campus. And of course, we've been looking at 3D concrete printing or additive manufacturing and large scale that a lot of universities and companies are looking into, because it's such a promising construction method that we can explore for the AEC industry. This was just one of the examples that we did, an exhibitions piece for the museum in Futurium in Berlin. And the advantage of concrete printing, of course, is that you have a distribution of material layer by layer, and you can go as complex as in the requirements of the setup that you have, but you can really create intricate details on a very small and also a very complex geometry on a large scale. We invited our students to partake in a challenge to look at office spaces and to optimize the construction type of steel concrete. And we want to look specifically on the slab structure, because a lot of the mass, about 65% of the mass, is actually allocated in slab masses. So we wanted to reduce that by at least 30% to the conventional steel concrete construction type. Also, one thing that we wanted to focus on is modularity. We wanted to do a prefab construction and then assembly on site. And also, one of the biggest points that we wanted to focus on is formwork. So we do not want to lose any formwork or create it with a material that cannot be reused or which is maybe not sustainable. And we wanted to create a formwork which is actually going to be then used on site to be not lost but be permanently inside the structure. So we took a very simple geometry, which is a rectangle. You can see one very simple modular of a slab, maybe 4 by 2 meters, which is a prefab maybe. And we also wanted to look at a bit of the design, so we're playing with the inclination as we print along. So we print this actually vertically up, so it's all one piece and one go. And we wanted to print it vertically up, and playing with the speeds and the material distribution, you can also create interesting three-dimensional variations of the form, like here the inclination, as you can see, as we go upwards. And the basic idea behind the structural optimization was that you have any slab and you distribute material only there where it's actually needed. That, of course, has a few variables, such as the support structures. In our case, we have columns. This could be symmetrical or asymmetrical. Here we have just 3, just to explore this idea. And then using Galapagos evolutionary algorithms and Karama 3D for the structural optimization, we did an iterative form finding of this landscape, if you will, that is then formed by just the material distribution under bending stresses and bending moments. And then to actually print this vertically up, we also introduced a rib structure to it. And you can see that the rib structure here then allows the slab to actually be fabricated, so stay in place when it's actually printing. We did some investigations and calculations for that, adjusting a bit of the volume centroid. And the whole idea was then to take this and actually 3D print this. We needed to create the detailed and intricate print path. The biggest challenges here was the connection points. So we had this meandering geometry implemented there. So you always have something to print on as you go along up there. This becomes a bit more evident if I play this video here. You can see that if you would not have this meandering geometry, then the print would actually just go into something to avoid, and we wanted to avoid that. You can see that these complex meandering geometries allow the slab to actually be printed vertically. And then, of course, we also have the inclination just by the mean of controlling the speed and the distribution of mass Another innovation alongside the structural optimization was the acoustical optimization. We implemented small voids that are actually adopting the Helmholtz-Resonatoren functionality, where you have a difference in air volume, and then hereby you can absorb frequencies ranging from 100 to 2000, depending on the usage that you want to have, which we can then actually fine-tune as we go along. This is how it looks. If you simulate it, of course, we needed to create the 3D print file for that, the G-code, if you will, and this is all done automatically for the geometry. This was the first kind of mock-up that we did, just to test if the overall connection points and the meander geometry works out. Also looking at the acoustical openings, and actually it turned out to be very successful. So all of those elements are actually prefab elements that will be then transported onto this building site. Then they will be assembled alongside with the reinforcement and then filled up with either concrete or any kind of fill material to a monolithic finish, basically. So this was the idea that we investigated a year ago, and now we have, of course, been doing much more research and actually have also a few different routes that we're going through, looking at different ways to actually accomplish the same goal, which would be the optimization of slab geometries. This is just one preview of our upcoming work. We're just going to combine both methods, the one that I just showed you, and also this kind of waffle structure, which also has the structural, acoustical, and also thermal optimization into it. And the whole idea behind this is that we really want to create a streamlined process that can be used within the next years in the AEC industry to optimize the steel concrete fabrication processes. So this is our aim, and I hope that this small overview of the paper gives you a better understanding of it. And please feel free to reach out to us or to me. I would be very looking forward to get in contact with you and discuss a bit more future potentials for 3D printing for the AEC industry. Thank you very much.